Question number 15 of the PhilNITS FE afternoon portion of the exam. In this question, we are given something about engrams, which are continuous sequences of words, symbols, or tokens in a document. Engrams of text are extensively used in text mining and natural language processing tasks. An engram model is built by counting how often word sequences occur in corpus text and then estimating the probabilities. The figure shows an example of the unigrams, bigrams, and trigrams of the example sentence. ID PEC includes members from 6 countries. We can see from the example of a unigram, a bigram, and a trigram how the output should go. If it's a unigram, each word would be put in a slot. If it's a bigram, there will be 2 words, and the sequence would be arranged in this way. ID pack includes first 2 words, and then for the second slot, we use the second word in the first slot and then add a new word, the new word from the sentence. That's why it becomes includes members. And then for the third slot, we use members again here, and then the next word from the sentence, which is from, and in that way we can form the bigram. For trigram, instead of 2 words, we go and put 3 words in a slot. And for the second slot, we start off first with includes members, and then add the new or next word that we can find in the example sentence. The description that follows gives us a little bit more explanation how it's supposed to work. If the argument for n is 1, then that's a unigram. That's supposed to mean a unigram. And if it's 2, then it's a bigram. Layman text is a string of words separated by a space. So we know that each word is a word because of a space that separates each word from each other. The operator plus here signifies both arithmetic calculation of integer data type and also concatenation of one or more strings into one string. Okay, table functions. Alright. Now, what we need to do next is look at the program and figure out where the blanks. We see there's blank A and there's also blank B. And for the answer group, we can see that I didn't choose immediately the correct answer, although I ended up choosing letter I, which is the correct answer eventually. I think I first tried out a few choices. Maybe before going to letter E, I chose another letter because I think I needed to see if the output would be right or wrong, and eventually I thought that E might be the answer. But as I was doing the next part, which is to test the idea, I thought that it looks like we need to do a -1 here, and maybe because there's a -1 here, we'd need a +1 here as well. And if we plug in those updates, we can see that the output would be correct. Now for the program, if we attempt to test the idea and see whether it's really letter I or I just made a mistake. Then we plug in the answers in this way, and then instead of going immediately to I, let's also check letter E. And what we can see is letter E doesn't have the +1 and the -1 at the end. And if we are doing unigrams, that means n is equal to 1. And if the length of the input is 6, then if we make use of the answer of letter E for blank A and B, what we get would be 6 minus 1, which is 5. And for blank B, it'll be 1 plus 1, which is 2. I is 1 because if we start off first with 1 here, then for the second loop, we would be at 1 as well because we're starting from I. And then we have to do a +1 because we're doing unigrams, and that's where we get 2 here. Now, the thing is, with the second for loop, what we are gonna do when we're inside the for loop is add the words. And if we're doing unigrams and our B is saying we get 2 words, then that's wrong already, right? Because we only need 1 word if it's a unigram. So in that case, if we have this equation already, then what if we do a -1? Then that should fix it, right? And that's why I had to add the -1, and that way it looked like it was gonna be alright. Now if we do another one, n is equals 2, will we be able to come up with the correct answer? And if it's n equals 2, that means it's a bigram. So if we plug in the values, 6 length 6 minus 2 equals 4 without doing the +1 first. 1 plus 2, starting off with the first word, first position, plus 2 gives us 3, minus 1 gives us 2, which is what we're going for, 2 words. Okay? Now, how do you explain the need to add +1? I think that if we reach the succeeding parts towards the end, would we still be able to get the correct answer? And as it turns out, without the +1, if we reach 4, we eventually would not need to do the remaining ones because we have 6 as the length, and if we're doing 4 here as the last the last position of I, and we're going for 2 words, then we get only 4 and 5 because we need 2 words, right? And we're at 4, so 4 and 5 we get those words, but the last word, which is at position 6, we don't reach that anymore. So that's why we need to add +1, because if we can reach 5 and we're doing bigrams, which means we need 2 words, then 5 and 6, those 2 words would be the last words that we'll get. And in that sense, the correct answer would need the +1 and the -1, and that is letter I.